So hello everyone, my name is Jonathan and I did part 3 for the project. For number 1, we had to choose between the 90, 95, or 99, and our group used 0.95 for the C. So the X bar would be 7.5, the S would be 0.1537, and N equals 12. And then, so C equals 0.95, so our alpha is 0.05, and the alpha divided by 2 equals 0.025. And to find the degrees of freedom, we would use the formula of n minus 1. So we would plug the numbers in, and we would get 12 minus 1, which would give us 11. And to find our critical value, we basically did the inverse t on the calculator, and we plugged in the numbers that were needed to be there, and we got 2.201 for our critical value. For the standard error, this is the formula right here. We plugged in the numbers, and we added 2.201 multiplied by the s, which is 0.1537, divided by the n, but divided by the square root of n, which would be square root of 12. And we did the math here, and we got 0.0977 for the standard error. For the confidence interval, we use the formula given here, which is x bar minus e less than mu less than x bar plus e. So we added the numbers, plugged the numbers in here, and we got 7.5 minus 0.0977 less than mu less than 7.5 plus 0.0977. For the left side, subtracting it, so we got a total of 7.4023. And for the right side, we added them, and we got a total of 7.5977. So that's given right there. And then we came into a conclusion of that the confidence interval for mu is 7.423 and 7.5977 tap pH when the C equals to 0.95. And here we have our sketch here. We have the C equals 0.95 in the middle, the alpha divided by 2, and on the left side and right side of 0.025, and then our critical value of 2.201. So for number 2, we needed to create a 80% confidence interval for the mean. So we started off with the x bar equals 7.5, the s equals 0.1537, and the n equals 2. The c equals 0.80 as given in the question. So alpha is 0.20, and we divided the alpha by 2, and we got 0.10. So our degrees of freedom is n minus 1, so we did the math, and 12 minus 1 equals 11. And we got a critical value of 1.363 by doing it on the calculator with the inverse t option. And then to find the standard error, we would use this formula here given, and we would plug the numbers in. So it would be 1.363 from the critical value, and you multiply it by the 0.1537 divided by the square root of 12, and that would give us 0.0605 as a standard error for number 2. Number 3, we need to design a hypothesis test for the mean, and we would use any method covered in class. So we use the p-value approach. And in a sentence, our claim is that it has a two-tailed test where the u equals 7.47, the mu, sorry. And the sample is the n equals 12, the x bar equals 7.5, the s is 0.1537, and the claim is mu equals 7.47 tap pH. So then we go on to the H0 and H1. The mu equals 7.47, and for the H1 is the mu does not equal 7.47. For the test statistics, we got this formula here given. We would plug it in. So it would be x bar minus the mu divided by the s divided by the square root of n. So we would plug the numbers in. So 7.5 minus 7.47 divided by the 0.1537 divided by the square root of 12. So that would give us a total of 0.6761 for the test statistics, sorry. And the p-value was given as 0.5129 given in the calculator. And since 0.5129 is greater than 0.05, we would fail to reject the HO because the p-value is bigger than 0.05. So 0.5129 is bigger than 0.05 when C equals 0.95. So we would fail to reject that. And here's a sketch here given. So the p-values are the areas on the left and the right side, which is the 0.5129. And our critical value, or no, test statistic, sorry, is a 0.6761 given here.